We are going to start with SURDS according to our course outline. A SURD is defined as a positive irrational number written in the form nth root of a, where a, this a here is called the radicand, and n, this n here is called an order or an index. Examples of SURDS we have the square root of 3. When you don't have an index written there, we should know that there is always an invisible 2. So there is always an invisible 2 every time you see the square root of something. We have the cube root of 5, the fourth root of 7, the fifth root of 10. All these are SURDS. Remember that by definition, a SURD is a positive irrational number. We have it here. A SURD is a positive irrational number. What's the meaning of this? A. For a SURD to be called a SURD, A should not be negative. This A here should not be a negative. So we should not have a negative radicand. And the same A should not be a perfect root of something. E.g., or example given, which of the following are SURDS? This is how questions come. Which of the following are SURDS? Let's look at the square root of 7. The square root of 7, we know that 7 does not have a perfect square root. Therefore, it is a SURD. But 9 has a perfect square root, which is 3. Therefore, the square root of 9 is not a SURD. We don't have a perfect square root of 12, therefore it is a SURD. We know that the square root of 25 is 5, therefore it is not a SURD. The cube root of 64. We know that the cube root of 64 is 4. 4 is a number that you can multiply 3 times by itself to give you 64. Therefore, since the cube root of 64 exists, it is not a SURD. So what am I trying to say? For a SURD to be called a SURD, it must be positive and irrational. So today we are going to end here. Tomorrow we are going to continue with the subtopic types of SURDS. There are 2. We have number 1, pure SURDS. Number 2, mixed SURDS. So make sure before you sleep today, you know these ones so that it becomes easy for us to continue tomorrow. Have a good night.